Alright, so for today I was thinking to continue working on the chess game engine that we are doing. And so far we have some really basic, being able to make some moves by clicking pieces around. But right now you can make illegal moves, like you can move pieces randomly. You can also just take pieces, you know, you just move the pieces on the board, but you don't really have any rules. So I was thinking that today maybe we can try to figure out how to implement some of these rules, right? So the first step would be having a function that checks for valid moves and being able to somehow visualize those valid moves on the board. So for instance, if I click on this pawn, maybe I want to see some circles where I can actually move it, right? Or if I click, I mean, if I click on this knight, maybe I want to see the moves like here, or the other one would be here, I guess. So, stuff like that. And I guess first step would be to just be able to make moves like that, but make them valid. And then we'll figure out how we can maybe make some more complex stuff, like being able to check your opponent or capturing pieces. I mean, capturing pieces already works, but it's not valid most of the times. Like, you can actually just get the king instantly. So that would be the idea. Okay, so let's continue where we kind of left off. We have this function chess valid moves that I was thinking to implement, and the idea is that once we click on a piece, I would like to have this function executed and get an output with the valid moves, and then we might want to draw those valid moves. So that would be the goal. Okay, so we can come down here where we have mouse down action, right? And this is something like if a square is selected, then we make the move. Otherwise, if we don't have anything selected, we set it as selected and we take the square. But at this point, we might want to check if we have a piece there, because if I click somewhere like here and then here, it breaks it because it moves nothing. So yeah, I guess that's also a good point. Maybe we want here like some kind of if statement to check that we have something there. And then obviously maybe something like chess square get, and then we have the square is not equal to chess none. Something like that. Yeah, it's still annoying that we have to actually, so if I just do that, it won't do anything. Okay, so it works as expected, but again, I would like to see the moves before I make them, and also validate that the move where I want to move is actually good. So I guess the first step is to try and figure out what piece we have on this square, because if we have nothing, then we don't have any valid moves and stuff like that. Do I have a DS dynamic array clear? It's weird. I thought I had a clear, but I don't. I mean, the easiest way to clear an array would be to set its length to 0. So that's a good way to do it. But anyway, doesn't really matter. So the first step again would be to try and figure out what piece we clicked. And besides that, I think the moves should actually be maybe a global variable. What do you think about that? Because yeah, I really think it should be a global variable, because each tick, I want to keep showing your moves. So if I make it a global variable, I come here and do this dynamic array moves. So these are like the valid moves that you can make. Let's initialize it here. So I'm gonna initialize the dynamic array init moves, and I mean init with allocator, right? We need to not forget about the allocator. Last time I spent like a lot of time debugging because I forgot allocator. Size of I vector, and here let's pass in our allocator. So we just initialize our dynamic array, and yeah, I think I want to have a clear, but we'll see. So once we select a piece, I would like to have this clear function on our moves. And I mean, clear should be pretty straightforward what it's gonna do. I mean, it's extremely weird that I don't have a clear function, but the clear, it's the most basic function you can do, so that's why I'm a bit confused. It's something like this, just setting the count to 0. It's like not deleting anything, but it's resetting the count. So now if we append something new, it's gonna override the old items. So that works for me. Okay, so we are able to clear the dynamic array of moves, but maybe I want to do that inside of this function because it's gonna make it simpler. So we don't need this extra argument. Nice. We could think about, okay, what piece do we have here? So the piece could be something like chess piece chess square get. So we get the piece, right? And for the piece, we should check if it's one of these. That would be the goal. So maybe first things first, we could check if piece, should I do piece? No, it's chess none. It's not really if I do and, I have to do, yeah, I do have to do and, but that's weird, like 0 and 0. Wait, what? That's kind of awkward. Wait, what? How can I check for the piece? I mean, I could do an AND with 111, right? But can I have a number like this and then say if it's equal to piece or like chess none? Right, something like that maybe I have to do. This gives me the piece and the color, so I could have like piece type is equal to piece and 0b111, right? And then I'm gonna say here piece type but we can even make a switch to make it simpler. Piece type, and obviously we have case chess. Let's do chess pawn something something, and then default is gonna be for none, and here we don't do anything, right? But for instance, for a pawn, that's gonna be interesting. Because we have to take into account like captures, moving from the first row 2 times if it's like its first move. So yeah, that's gonna be quite interesting to figure out. We might even need this color, right? Which is gonna be piece and 0b110000, and these are like flags because let me put 00 because I said okay, let's make this as an enum, and the first 3 bytes is gonna be for the piece type, and the last 2 bytes is gonna be for the piece color. So I think that could be nice to use. So they work like flags when usually you work with these kind of flags on microcontrollers, so I guess. But yeah, maybe the piece color is important for this stuff. Okay, let's try to have a function chess valid moves pawn. What about this thing? And obviously I still need the square. What's a bit annoying is I call it square, or like it's an IVEC2, and IVEC2 is X and Y, but it's not like row and column, which is the naming convention that I usually like. It's kind of annoying, but it's fine. It's still fine. We can, because right now we have that printing, so we can actually print things, and that's pretty good. Okay, anyway, so we have chess pawn, so we are going to do return chess valid moves pawn square, and I use return here because I just want it to do only this case. I don't want it to fall through another case. Okay, so for a pawn, what I'm interested in is that if it's the white pawn and it's on the second rank, then it can make a move like not like this or like this, right? That's what it can. It has by default the option to do these two, unless it's blocked. Like that can also happen. So and it also can make moves like this or like this, right? It can go to these 4 squares. So now we have to decide which ones of these squares are actually available to go to. So if there are some pieces, enemy pieces on the left or the right, it can go there, and then for the forward it can go there only if it's empty. So let's try to think about that. Let's try to see how we can actually get it. So, and I guess it can always go to these 3, so we can have this as a special case, this second step. So let's look at these 3 first. Let's look only at the first 3. So I guess what I'm gonna do, pretty simple, is just create the positions, right? So forward left, let's call it F, or I mean we can do just forward. This is for the forward position. It's gonna be square dot, and yeah, that's the annoying part. Maybe I'm just gonna call maybe I'm just gonna make another structure like IVEC, but it's gonna be called square T. I think I had square T, and it's gonna have file and a rank, right? So it's column and row, but usually I haven't. Okay, so pixel to square is gonna be square T, and file rank, I guess. So this is gonna be a square T. Ew. Oops. So the width is obviously gonna be the file, and the height is gonna be linked to rank. So here is gonna be what? Rank times width plus file, hopefully. And here we have the same thing. It's file. Oh no, this is square T. Yeah, I mean, I feel like it's still really difficult to, you have to think about how to use X and Y, but then you also have to think about something else. It's like extremely annoying. Like, try to make sure you have to only focus on one thing. It's becoming way too, I mean, even for me, sometimes it feels really hard to use X and Y for some reason. I don't know why. It's like really annoying. Most idiotic thing ever. So square T. And we can try to make sure, so we can do log C string clicked on %d square dot file square dot tank. Yeah, let me just that's actually hover. So let's try to hover. Oops, something failed. What? Wait, what the fuck? ds.h, but it's oh, it included ds.h for some reason. Okay. And here is still comparing 155. Okay, so this has to be a square T, and here a square T. But right now it's not doing anything, so that's all good. Okay, everything is working fine. So if I hover over something, it's gonna be 0.7. I mean, I guess it's fine. 0.7. It's like what do I print? File 0 rank 7. I mean, it's the other way around, but it's fine, honestly. Okay, I mean, it looks fine. It looks fine. Okay, so if we go back to our valid moves, our pawn thingy, we can have a square T for the forward position, and we have file is equal to square dot file. So it's going to be on the same file, but the rank is going to be a rank +1, I guess. So this is going to be the forward position. Okay, so if chess square get at forward, if this thing is equal to chess none, then it means it's an empty square. So we can just say ds dynamic array append, and we are going to append to moves forward, and we need to pass the address because we are going to mem copy it. So we just copy this into moves. That's perfect. Okay, now we can look at, but again, this is just for the white pawns. So maybe I want to give it a color here just to not make it annoying and calculate it every time. I guess so. Maybe it's useful. Because for the black pawn, you have to do -1 there, I guess, for forward. So we could have int forward direction is going to be base color is equal to chess white. So if it's white, then we do +1, otherwise we do -1, and then we add forward direction because it's the same thing. Okay, so if it's not blocked, it can move forward. Nice. Let's see square T forward and like going left. So this one, it's kind of similar, but regardless of the color, you can go to the left. I guess the only way you cannot go to left, or like left hand side of the board, is if you go negative here. So that makes sense. Maybe we can check for that. And what can we also check? If the piece color is different, like it just has to be a different colored piece on the left hand side to go there. That's the only thing we care about. So if square, or I guess forward left dot square dot fuck dot file is greater than 0, greater or equal than 0, why not? And chess square get of forward left, and here I guess we could just compare the piece colors. just like this, by doing an AND with 0, 1, 1, 0, 0, 0. Then we can actually go to that direction as well, to forward, left. Right, does that make sense? We just check the position from the diagonal, and if it's a different color regardless of the piece, it can be any of these pieces, you can take any of them on the diagonal, you can move there. Straightforward, I'd say. Unless it's your same color. If it's the same color, you cannot move. So yeah. And what about forward right? Which I think it should be kind of similar. It's just plus. And here we care to be less than chess width. Let's not forget about using the right names. Oops. Oh, forward right. And we are going to add forward right in here. Okay. Another move, I mean, it's also en passant, but that's fucking annoying, would be checking if you can move to forward 2, right? Forward 2 would be twice forward direction, but we need to have nothing both on the first forward and on the second forward. That's the two cases, right? So you can, if you have a piece here, you cannot jump over it. That's the idea. And also you cannot go too forward if you are not on your second rank. So how can we get the second rank easily like this? Maybe we can just say int second rank is, if it's white, and that's now the annoying part, because numbers are kind of reversed fuck. Right, the numbers are reversed. Maybe I can unreverse them. Like I want this to be 0, 0, 0, 0, 1, and this to be 0, 7. Fuck. Okay, it's gonna be 1 or 6. Let's try to unreverse them, maybe. So that's that. Square rank. So if the rank is 0, it starts at the top. So I would say then this should be chess height minus rank. This should also be chess height minus rank. Then this part doesn't matter, it's just texture name. Then we have pixel to square. That's also interesting. Pixel to square for the rank is going to be chess height minus this thing. Right. Load fan, this is like loading the chess position, going like that. Here it's gonna be also chess height minus rank, obviously. Chess print board, this is also gonna be chess rank, chess height minus rank. And I think here as well, chess, char piece is gonna be chess square get. But here I need a square. Can I do just square t rank is equal to rank, file is equal to file? Does that make sense? I think so. And this one is also annoying because I have to do the same thing. So here let's do if piece is not like that, rank pixel I guess let's check if this works. Oh, no, it did not. Okay, let's go back to the drawing board. Fuck's sake, bruh. So file plus rank, I guess. Let's think about it. So we are trying to print the chessboard, right? We get the width, the height, cell height. Then we go from 0 to chess width, from 0 to height. I guess it's a light square if it's not divisible by 2, if it's an odd number, their sum. Then we get the file pixel, the rank pixel. I guess here we don't need -1. Then we fill the rectangle, we take the piece and we try to draw it. Let's see, but it's weird. Why is it doesn't look right? I mean, the king and the queen are reversed. And also I think this should be white, so maybe it was right, but the king and the queen are the other way around. Oh, no, it's fine, it's fine. Now it was looking weird because the squares were off by 1, so I think now it's fine. Let's js log c string %d. Let's see the square file and the rank. So this is 0, 0, 1, 7, 1. 0, 2, 0, 2. Oh, I forgot about the okay, I forgot about the +1, I guess, or a -1. What the fuck? So here when we do pixel to square, I'm doing chess height minus this division, which gives me a number between 0 and 8. So I need to do another -1. Okay, noted. And I guess these ones are fine. Not really, I have to do -1 as well because it's gonna be 8 otherwise. It's between 1 and 8, yeah. So I think now it's fine with this extra -1. And I guess here I should actually use the set function, just like this. So I should do set is. Right, I think that's the way to do it. Okay, we use set, here we use get, just so we have less opportunities to make it wrong. Okay, so now it looks fine. What the fuck? Okay. I guess for oh shit. Yeah, I mean, maybe the only place. So, wow, it's too much. It's too much for my fucking brain. So we should just print them in the reverse. So that's the only thing I should do. So let's stop with this bullshit. Let's leave it like normal, right? Let's use square rank and whatnot, and then when I print the board, that's the only place where I do chess height minus rank -1. So only when I print, and then when I do chess get and set, I do them in the normal order. Pixel to square, it's interesting though. Should I revert it? I don't know, we'll see. This one it's fine, it's using set and get, and this one is also using set and get, but I'm reversing the pixel, so like drawing them upside down. Oh fuck. Oh my fucking god, this shit's so fucking annoying. What the fuck am I doing wrong, bro? I mean, I want the rank to like 0 0 to be in this corner. I want, that's what I want. That's kind of good here because we convert this pixel to square. That works. You can see it's 0 0. Oh no, it's, oh yeah, it is 0 0. So that's good. That's the first step. Wait, it's actually working. Oh yeah, it's actually fine, kind of. Then it's fucking not. So pixel to square, it's kind of working as I want it to. Obviously, it's working. For fuck's sake, it's working. Oh my god, this is so fucking. What the fuck did I do? Okay. So, Jesus Christ. I mean, I would say I don't really care how the pieces are stored in this array. I don't care. That's the main point. They can be stored however they want to. It doesn't matter. So that's why I think this implementation is fine. It shouldn't matter how they are stored. It's like rank times width plus, it's like a row plus width. No, a row times width plus column. That's all this does. So it's fine. Then here, because our screen is like the canvas starts at the top, it's 0, 0, then for me it makes sense to do this minus here, because we want to read it the other way around. Okay. Then even loading this thing, it's fine because it's just putting the stuff in the array. That doesn't matter. And maybe when we draw stuff, it's also okay. So whatever, I just reverted some of the pieces, and in the end we kind of get the result that I was thinking about. But what I would like to do here with the pawn moves is to add some kind of, okay, you can only move the pawns here, and if you try to move any other piece, it's not gonna do anything. So that's what I'm thinking here. Okay, so what should we do here? So if you select a piece, I would like to run chess valid moves. Okay, so let's do chess valid moves at this square. Okay, and maybe after printing the board, I want to also print, or maybe inside of chess print board, I just want to print the legal moves, right? So that's what I want to do. So here we have chess valid moves. It's doing all of that, and inside of chess print board, after we do all the printing, I want to do something like for unsigned int I is equal to 0, I is less than moves dot count I plus plus, and now you can see why if you just reset count to 0, it's like you have a new array. Let's do square t square or something. It's gonna be equal to 0, and let's just say ds dynamic array. I'm gonna use getref, honestly. From now on, I think it's the better way to do it. So getref, it takes the array index and item. Moves I square. It's mainly because this, I mean, it can fail, but what do you mean about it? Void pointer. I mean, it's void pointer pointer, and you give it the address. Okay. This thing kind of returns error in case of an error, but ds unreachable. That's kind of the thingy. So, in case we get a move, I should just draw, or no, fill, circle. Interesting, I need calculation. Maybe I want a function that gives me like this one, pixel to square, but I need the reverse. So static void square to pixel, and it's gonna be square t square I vec to pixel. I don't know why I made it a pointer, but whatever. And it's gonna be something like this. Square dot file and square arrow rank, but all right. And we also need this part. Nice. and here is gonna be px.x, oops, and px arrow, it's arrow. Okay, nice. So square to pixel. So that's why I was thinking here maybe I can do square to pixel, and we give it, just give it the square and an address to px. Jesus. And when we draw this thing, px.y, shit, we need the cell width, I guess, for the radius. Cell width divided by 2 or something, and what color? Define square move RGB. Let's see what this thing is gonna look like. I mean, it's kind of annoying. Yeah. So if I click on this pawn, oh, it draws it in the, no, okay, oops, it draws it in the corner. So I have to do px plus cell width divided by 2 plus cell height divided by 2, and maybe here we'll divide by 4, so it's really small, just for you to see it, right? So now you can move, and it should also clear the moves once you make them, once you make a move. Oops. But it's like, why is it even a valid move, right? Whatever, we'll put this thing into something else anyways. I guess that's fine. I kind of don't like that we could just do something like this, but yeah, it's like whatever. Or we could also just replace that. I don't really give a fuck. So just like that. But yeah, why is it why was left okay? Oh, because there is a piece none. Okay, let's do then something like piece. So piece and I should also try 0x00111 not equal to chess none. Oh, it's and. Okay, and sharp piece, we can just declare it up top for the names. And also in here piece. So now it's gonna look for the left and for the right, and let's see. Now we can only move forward. Nice. This one can only take, nice. This one, oh shit. It killed itself because something went wrong here. Oh, did I forget about, I guess I forgot about second rank. Oh, and square dot rank is equal to second rank. All right, so let's check. So if you move forward and you make another move, you can only move once. Obviously, you can do that. So in here, we'll need an apply move function or something like that, like static void chess apply move. All right, so it's interesting. Selected square, it's already there. So let's see what we are gonna need here. I think only square, like target. So there's a target square, so I'm gonna call here chess apply move of square. Okay, and is selected becomes 0. That's that. That's that. Okay, and here we should try to do something like for unsigned int I is equal to 0, I is less than moves.count I plus plus, and square t pointer move is equal to null. We are going to take one of the moves, like yes, unreachable. So let's try to get a ref from moves index I into move. Okay, and we are going to check if move.rank is equal to is equal to square dot rank, and move.file is equal to square.file. That's when, I mean arrow, but it is what it is. That's when we can make the move. And we might as well just return afterwards. Let me just something like that, or just return. Otherwise you can't make the move. So if I click on this thing, it can go forward, but if I click anywhere besides, oops, I guess I want to clear the moves regardless after, maybe, but I want to do that only if that. So I want to clear the moves because you saw that if I did an illegal move or like I couldn't move, it just resets it, right? And you can click again on it. That's, I mean, it's, and yeah, the other pieces cannot move. It's only pawns for the moment. So that's kind of funny. It cannot take the king, what? Why can it take on the... What the fuck? That's kind of weird. Let me just go. No, not like this. I should go like this. This one works. Let me try again. Why can't it take the... What? What kind of weird edge case is that? So it's like on the left, right? So if it's piece, it's not piece color, and it's not chess none. Forward fire is greater or equal than 0. I mean, it is greater or equal than 0. What? Forward left. It's file -1 and a rank plus direction. I mean, luckily we have JS log C-string, so we can just %d, and then forward left dot file, forward left dot rank, maybe even the piece. Let's see if that works. So if I for 014, so it's for the file, 0 for the rank, which is correct, and 14 for the piece. 14 meaning 8. Wait, it's the king, it's 6, and white is 8. Yeah, so it's 16, it's right. So then why didn't it go into here? What the fuck is wrong with this guy? So bad. Oh. Whoa, what? 4, 0, 14. Okay, so it's 4. Pi is greater than 0. That's right. Piece is not equal to piece color. Let's just double check. Piece fucking color. And piece and oh fuck. I used X. So fucking dumb. Okay, now it's gonna work. That's why maybe I want some kind of macro for these numbers, but let's do a define piece flag, it's 0b 00111, and define color flag, it's 0b11000. So now everywhere I find this kind of number, it's gonna be piece flag, piece flag, piece flag, and then where I find this stuff is gonna be color flag. All right, so now it's a bit better. So if we go like this, king is dead. So yeah, that's kind of what I had in mind with the valid moves and stuff. Obviously en passant would be an interesting one to figure out, but how can we figure that one out? Right, that's kind of tricky. We might need previous move or something, and we might need to keep track of the previous move for that, because like you cannot figure out how to do that. Otherwise, it's impossible. Like you can look at this position and be like, okay, what if this guy moved one step and then one step? Like you cannot really tell. So we'll need previous move. That's what I'm thinking. Previous move, it's like previous start, previous end. So yeah, maybe that's what we might need to do. So square t. I don't know if I want to do that. Let's just pretend I don't really care. Let's try to do more pieces maybe. What if we do next case chess knight? Valid moves knight. Knight should be kind of straightforward because it can jump over pieces. So valid move knight. Doesn't matter the color, I would say. Unless, I mean, it kind of does. Color still matters because like for taking, being able to take a piece. Okay. So how can we do that? How can we check for the valid moves? I mean, it can go up 2 and right 1 or left 1 just by doing them manually. Shit. I mean, I don't really see another way. Like just maybe making the combos int rank, let's call it d rank. It's like d for the ranks, and it's gonna be pointer, and it's gonna be like for the rank. It can go, let's start clockwise from the first one, which is gonna be 2 up, 2 up, then only 1 up, then the next one would be 1 down, 2 down, 2 down, 1 down, 1 up. I think that's how it is. Wait. Okay. And then we have the file, and on the file we have -1, 1, 2, 2, 1, -1, -2, -2. Am I wrong? Yeah, it's -2, -2. Okay, perfect. So that's like the diffs if you think about it. If you have a knight in the center somewhere, it can go up 2, left -1, that's the first pair, then up 2, 1 to the right, and so on. So we have these 1, 2, 3, 4, 5, it's 8, right? It's gonna be 8. So now we should just have a for loop over these pairs and try to see if they are legal. So for int run signed int I is equal to 0, I is less than 8, I plus plus. Maybe I'm gonna call it rank diffs, file diffs, so that we can have something like rank diff is rank diffs I, file diff is file diffs at I, and we can have square t target is square dot file plus file diff, and the rank is square dot rank plus rank diff. So that's how we get a target. And now what I'm interested in is kind of something like this. So if target, target dot file, shit, we need this if statement. First of all, it needs to be inbounds, so it has to be greater than 0, less than width, like that. Maybe we can call it int is bounded. All right, then we can have something like int is free, and that's just chess square get target is equal to chess none, and we might also have the is capture chess square get the target, and the color flag is not equal to piece color, so it's the opposite color. And if is bounded and is free or is capture, that's when we are going to append this. We append into moves the target, and I could also do unreachable just for the memes. So that's how we are going to take the valid moves for the night. Hopefully, let's see if it works. Yo, it actually works. Holy fuck. I mean, kind of nice. We have some moves. I mean, we still don't have turns, right? It's just like an RPG. Or no, RTS, right? That's the kind of game where you have real time. Yeah. But we still need to do bishops and rooks and the queen for the valid moves. Okay, so let's maybe try to do chess bishop, chess valid moves bishop square and piece color, because obviously we might care that it's a different colored thingy. Now I'm curious if Copilot is gonna be able to do something with this one. Let's evaluate how good Copilot is gonna be. So I'm gonna copy paste, oops, the bishop function, and let's try it. I mean, I'll do the other. If bishop is gonna be kind of similar to the rook and the queen. They are the same, but they move on different diagonals and column and row. So I'm curious if it's gonna work. So okay, nice. So it found my knight approach and it copied it, which is kind of cool. So it's looking on the diagonals, obviously, and then it takes the diff. Then it not only takes the diff, but it tries to move for like a certain distance, right? So it goes multiple steps, and if it goes out of bounds, it stops. It finds a piece. If the piece is none, it appends the thingy. If the piece is another color, it still appends the move. But if it's the same color, it stops because it's blocked. Okay, let's see if this actually works. This would be quite interesting. So we cannot move the bishop, but if we wait. Okay, it's fine. It was a bit weird. No, it's fine. But now, holy shit, it can actually move. That's pretty cool, right? So for the rook, it's gonna be exactly the same, but what I'm gonna do here, so moves rook. For the rook, it's actually with 0 here, I think. Let's think about it. 0. So it goes up and up only, then it can go down and oh shit, and 0, and then we have 0 here, 0 here, 1 minus 1. So this is basically the rook moving. It just changes the divs. The rest is the same. Let's just double check. So case chess rook. Let's double check. So if we nice, so it can actually just move. That's pretty cool. And the last one would be the queen, right? And for the queen, what's also pretty cool is the queen is basically a rook and the bishop combined. So we are just going to copy paste the diffs and we are going to combine them. So we are going to combine the bishop and the rook. That's kind of impressive that it was kind of this easy. I mean, we still have to think about okay, let's take the queen out. Oh shit, what? Oh, I mean, that was the only problem. And what would be actually cool, but I won't do that, is we could combine the rook, the bishop, and the queen into only one function. But yeah, I mean, come on, let's see. And now the queen can move anywhere, pretty much. So it can just kill the entire board. But yeah, you can see it's on the diagonals, on the lines. So that's kind of cool. So yeah, because if you think about it, the bishop is just the first 4, the rook is the last 4, and the queen is all 8 possible moves. So yeah, maybe it makes sense to combine them to have less code, but I don't really care. And the last one is gonna be the king. For the king, it's, I would say, even simpler. It's exactly the same thing as the queen, but it can only move one step, so no longer using J. So it's gonna be just this, oops, but without J and without J here, right? So it's gonna be just this. So if we take the, fuck, what? King. What? It didn't even work. Moves king. There's the king. It goes up until 8, takes the diff, does some additions and shit. So why doesn't the king work? Not completely sure. Square plus diff. Jslog sister percentage d. So finally we have I mean, printf debugging is the best. 5.1. I mean 5.1, it's this one, right? 0, 1, 2, 3, 4. No. Oh, it I forgot about break. We don't want to break. So yeah, if it's here, we just want to continue. Okay, so if I try to move the king, it can go any direction, but it's only one. Obviously, we still have to do something like you cannot move your king into check, maybe castle, maybe having turns, right? But I think it's pretty cool that we actually have this kind of, wait, how do you do the score checkmate like this? All right, so being able to not go in, obviously, like wrong moves and stuff like that. So yeah, but I think it's pretty cool that we got to this point where we actually have the valid moves, but we still have to do turns. We have to do, you know, these special moves like en passant, and which doesn't exist right now. Also castling, which doesn't exist right now. And if you get into a check, then be something like you have to do something about it, right? And not being able to move your other pieces. So I think for today it's a pretty decent progress. So yeah, let's try and see what we can do in the next one. So until then, see you.